So, thanks to Ian Phillips for coming today. So Ian, as you can probably tell from his accent, comes to us from the UK. So he earned his BPhil at Oxford and his PhD from UCL. He then spent many years as a prize fellow at All Souls, where I think your main responsibilities were to drink sherry and occasionally write some papers, which, you know, makes me envious. And then taught at a number of different institutions in the UK before hopping over the pond for first a visiting position at Princeton, and then to become the Bloomberg Distinguished Professor of Philosophy and Brain Sciences at Johns Hopkins, where he's jointly appointed in the philosophy department and the psychology and brain sciences department. So he's won many awards, but most recently, I saw on Facebook the Leibowitz Prize with Ned Block. So this is a prestigious prize given out by the American Philosophical Association each year. And it was very nice to see some people who work in the philosophy of mind receive it. And it also comes with a very, very generous monetary award. So drinks are on Ian afterwards at the bar. What I like about Ian's work is that it really nicely marries an interest in deep problems in the philosophy of mind, especially perception and consciousness, with an equally deep familiarity with cognitive science, and especially vision science. So it makes him a really sort of perfect speaker for the CVR. So just to give some examples of some of the cool stuff I've read that he's worked on. So he reinterpreted Sperling's classic partial report studies as involving a postdictive effect. So it's a really, really cool paper. And that helped to block some arguments that people have given in favor of phenomenal overflow, the idea that consciousness, there's more to consciousness than what you can report. He also has a really beautiful discussion of the Mueller-Lyer illusion in another paper. In the context of naive realism, if you're wondering what naive realism is, it's a view that about the nature of perception that one acquires by living or being born in the UK. And I'm really curious to see which of those it is. So now that he's in North America, you know, was it just the water over there, or is it genetic? And so I guess we'll find out soon, eventually. He has several papers challenging the existence of unconscious perception, including Blindsight, which he'll be talking about today. Though I'd say his greatest accomplishment, for which I'll be forever grateful, is supervising Sam Clark and then sending him my way for a Vista postdoctoral fellowship. He's been absolutely wonderful to have here. So whatever you did right in your supervision there. Today, Ian will be talking to us about Blindsight. So the title of his talk is Bewitched by Blindsight. And I give it to you now, Ian.
Thanks so much, Jake. I think what I did with Sam was just let Sam be Sam. So I take no credit. But, yeah, really delighted to be here, and I'm sorry it's not in person and I can't spend my prize money on taking you out for sherry or Canadian beer. So today I want to discuss the famous phenomenon of blindsight, and in particular the argument in a forthcoming paper of mine where I reject the standard view of blindsight as involving unconscious vision, and argue that the sight in blindsight is degraded and qualitatively different, but nonetheless conscious vision. And that, as Jake was saying, is part of a larger sort of campaign to at least question in a skeptical manner whether we should believe in the existence of unconscious perception. So I'll start out with a kind of short review. Then I'm going to consider 5, if I think I have time anyway, arguments against the interpretation that I favor of blindsight. and show, I hope, why they don't work. And then finally, I'll turn to offering some more positive reasons in favor of the view and drawing some broader lessons. Okay, so let me start by introducing you to this man, Graham Young, or GY as he's known in the literature. And when he was 8, he was involved in a traffic accident leading to intracranial hemorrhage and ultimately to destruction of almost all of the primary visual cortex in his left hemisphere. And the consequence of that was a right homonymous hemianopia with about 3 degrees of sparing corresponding to of foveal vision corresponding to this portion of spared cortex at the occipital pole. And from his perspective, and here he is talking in an interview with PBS he did 20 years ago, the consequence was that he went blind on the right. He's lost all the vision to his right, he says, and then he reports the obvious functional consequences of that. When he was 8, he used to walk into lampposts. Clinically, that's confirmed by perimetry. So here's a kind of standard example of that. And here, Sturrig and Barth asked him to indicate whether he saw a bright white stimulus presented at various locations in his blind fields. And as you can see, apart from a few white circles corresponding to positive responses, and again, corresponding to that spared cortex at the occipital pole, all these radii are comprised of black circles where the stimulus was presented and he reported not seeing anything. So it would seem he was blind. But of course, I wouldn't be talking to you about him today if that was all there was to say. It seems that he's not merely blind, but he can also see. So this is the paradoxical condition of blindsight. So what does it mean to say that he sees? Well, it means that there's residual visual function. And that involves not just visual processing or ocular reflexes, but crucially, from kind of my perspective anyway, voluntary responses, voluntary discrimination. So here's a figure from a paper by Weiskrantz and colleagues from the mid-90s, showing both in 2AFC and forced response designs, the capacity to discriminate motion direction. And so what you can see here is slightly hard to read this chart, but these stimulus speeds of 5 and 10 degrees per second, GY is reporting no awareness whatsoever on a trial by trial basis, but achieving in this case a 2AFC design 80 something, even 95% accuracy in saying whether the motion is horizontal or vertical. So lots of other studies, I won't run through them all, but studies of so-called effective blindsight, where it seems like GY can discriminate between pairs of facially expressed emotions, not at 95% accuracy, but nonetheless significantly above chance. Earlier work with patient DB seemed to suggest that it could discriminate simple shapes and orientations of lines. So again, this is slightly hard to read, this chart, but what it's showing is either X's and O's or horizontal and vertical lines presented at various sizes, that's what's on the X-axis. And in each case, you're getting 30 presentations. So chance performance would be 15 out of 30, and this is 15 here. So all of these performances are significantly above chance. Okay, finally, GY can also perform well above chance in detection of simple high contrast stimuli. So here's a paper by Bob Kendridge and colleagues presenting a very high contrast black circle sort of flashed 3 times in quick succession at various locations in the blind field. And if you just look at this location here, the first number here, 100, is the number of times out of 100 that GY was able to say in which of 2 temporal intervals the stimulus was presented. So it's 100% correct, and that the 0 is the number of times he reported there being any awareness on a trial-by-trial basis. So despite reporting no awareness, he's 100% correct. And this number is the chance that he might have pulled that off by just guessing. Okay, and one more very famous different case is patient TN, who here you can see walking down a corridor, navigating various kinds of office, bits of paraphernalia with Larry Weisskranz right behind him. And TN had the misfortune to suffer 2 strokes in quick succession, leading to extensive damage of both visual cortices. So he seems to have blind sight throughout the visual field. And so with respect to this walking down the corridor navigation task, as it were, he reports not knowing how he does it. But as you can see, it seems fairly successful. Okay, so with that all in the background, I'm sure many of you are familiar with it. It seemed to many, including Weisskranz, who is credited with first really investigating and discovering this phenomenon, that blind sight was a revolutionary phenomenon. He says in retrospect, writing in 2010, it was immediately obvious that the phenomenon of successful performance without awareness across a startlingly broad range of tasks must have a bearing on the neural and philosophical aspects of consciousness. And here's one philosopher who totally agreed with that, Pat Churchland, says the revolutionary blind sight results knocked the stuffing out of the, quotes, obvious assumption that awareness of a signal is necessary for an intentional response to that signal. And that's really, I think, the textbook view. So I won't read these quotations out, but here are just 3 vision science textbooks that I picked up, and all of them present blind sight as a matter of the ability to act or react in an intentional manner without conscious awareness or visual experience. And what I wanted to do today is motivate and defend a very different understanding of what might be going on. So this hypothesis, which I'll call the blind sighter's qualitatively degraded conscious vision hypothesis, really takes its cues from critiques of early work on so-called subliminal perception. So actually, some of those were done here in Johns Hopkins by Peirce and Yastro. And the kind of experiment that was done in the late 19th, early 20th century involved reducing the perceptibility of a stimulus, like a card maybe with a letter or number on it, until the subject would declare that they couldn't see what was on the stimulus, so couldn't see what the letter or number was. And then asking the subject to make forced guesses about whether it was an X or an O, whether it was an odd number or an even number, or what have you. And the results were very striking. They were the sort of thing that people would do in their classroom and to significant effect. Subjects were significantly better than chance in making those discriminative judgments, even when they declared they couldn't see what was being presented. And impressed by that kind of result, various early theorists, here's Boris Sidis writing in a monograph in 1898, drew pretty heady kind of conclusions. So Sidis writes that he thinks this body of work tends to prove the presence within us of a secondary sub-waking self that perceives things which the primary waking self is unable to get at. With the advent of signal detection theory in the 50s and 60s, a rather different interpretation of this body of work came into ascendancy. And on that interpretation, the results essentially showed that a weak conscious signal might fall below a conservative subjective response threshold for seeing or for detection, but nonetheless be sufficient for facilitating above chance performance in the relevant discrimination task. And in a pretty important critique of early work on blind sight, Campion and colleagues made a number of complaints about the early work, many of which were just addressed, but also raised in effect the same kind of issue, suggesting that blind sight might similarly just be thought of as the effect of using different decision criteria with degraded vision. And sometimes that was responded to as being the hypothesis that blind sight was just degraded normal vision. Weisskranz has a paper with the title, "Is blind sight just degraded normal vision?" And I don't think that's the right way or a necessary way of thinking about the hypothesis. There's no reason to think that blind sight is normal, whatever that means. It might be really interesting and distinctive in its profile. The fact that there's such a serious lesion of the visual system and subsequent degeneration and reorganization in different patients plausibly yields qualitative differences in the vision. So the key thing I want to emphasize here is that for all that, the vision might be conscious, but its conscious nature might be disguised by a conservative response threshold in the manner that the early critique of, or the signal detection theory critique of the early work on unconscious perception would have you think. Okay, so let me just run through how that picture applies to the various tasks we began with. So first, on perimetry, the view says that GWise is actually dimly conscious in various locations in his blind field, but his subjective response criterion is such that that dim conscious signal is reliably falling below it, and that yields the perimetry results we see. How does that square, though, with the detection task that I showed you from Kentridge and colleagues? I mean, they're both detection tasks, so what's going on? Well, the important thing about this task is that it's a forced choice task. So the task is, in which of these two temporal intervals is the stimulus being presented? And in that task, it's not an option to say neither. I didn't think it was present in either. One has to be chosen. So even if the stimulation falls below the subjective response criterion in both intervals, well, it will be noise in one that will be falling below that criterion. Still, one has to be selected. And if there's a signal that's reliably higher than the other, then if GY just chooses the strongest signal, as is the overwhelmingly natural response strategy, then you'll be able to reveal that performance. So it's perfectly consistent that in a two alternative forced choice detection task, that you'll get above chance performance, even measured by percent correct here, but you don't see anything in perimetry. Okay, and a similar story is going to be told about the forced response tasks, but in those, such as a task where you have to say whether a line is horizontal or vertical, we can depict the decision space in the following way. This follows Macmillan. And here we can think of the X and Y axes as, in effect, indicating the detectability of the vertical or the horizontal line. And the key point is just that even stimuli which fall below, the sensory response to which falls below a detection threshold, which is this dotted line, may still be discriminable. Now, with GY, this can't be the decision space, given that lots of the, as it were, the lines will yield sensory responses above this criterion. We do have to postulate a particularly conservative criterion to explain what's going on. And that's a feature that the account I'm proposing is going to have to explain. So the important point just for now is that a simple conscious perception only plus conservative response threshold can account for the patterns of performance and reported awareness we've seen. But should we believe that account? So what I want to do first is look at 5 arguments which have convinced people that that kind of picture is really untenable, and hopefully convince you that they're not good arguments. So the first thing that is often said is that, but we can match performance across the two fields. And in the blind field, you don't get reported awareness, but in the sighted field, you do. So Weisskranz presses this point in various places. And it's absolutely true that D prime, an objective measure of sensitivity, can be matched across the blind and the sighted fields, and awareness only be reported in the sighted field. And we might imagine, choosing some moving stimuli such that we can get 95% or 80% correct in the sighted field, and thinking, well, okay, but same level of performance, but in the blind field, there's not been, no reports of awareness are found, but in the sighted field, there very likely will be. The key question for us is, does that pattern show that the signal in the blind field is unconscious? Is that the only way of understanding such differences in reported awareness despite matched performance? Well, the critical point I want to make here is that matching D prime does not imply that the subject is setting the same criterion with respect to the sighted and the blind hemifields. In particular, the so-called criterion contents that are being used to make the discrimination in those two fields may differ. I mean, put crudely, the stimuli may look really different to GY in his sighted and his blind hemifield, consistent with there being equally discriminable. So this idea of differences in criterion contents was first really put on the table by Kahneman in a discussion of meta-contrast masking. So he was drawing on work of Sperling's then. There's a really nice discussion of this in a paper by Costa and colleagues from last year. But the basic point here was that in a meta-contrast masking paradigm, the detection of the masked stimulus, the target, can be founded on all sorts of different criterion contents. Like in some presentations, it might be that the subject does it on what from their perspective is the seeing of the target in a very clear way with a sharp and definite contour and so on. But in other conditions with different stimulus onset asynchronies, the way the subject might detect that there's a target there might be because the mask differs in various ways. Maybe it looks different in contrast or brightness or seems to move in a certain way. All those might be different ways of doing the task. And that actually is kind of really relevant, I think, to studies of so-called relative blind sight. So this is a study done by Hakwan Lau and Dick Passingham in 2006, using a meta-contrast design. Subjects had to discriminate whether a diamond or a square had been masked by a meta-contrast mask. And what they did was to exploit the U-shaped function of the meta-contrast masking function. So they varied the stimulus onset asynchrony, producing this function, and then found two different points on it where the performance was matched in the discrimination task. They did this by percent correct, and looked at whether the judgments on a trial-by-trial basis of how the discrimination had been made varied. So they asked subjects, A, was it a diamond, was it a square? B, did you do it by guessing or did you actually see the thing? And they found that seen guess judgment varied at these two SOAs despite performance being the same. And they interpreted this in terms of what they called relative blind sight. In effect, the idea was that at one condition, here you've got more of a contribution of unconscious signal than you have here. So it must be unconscious signal somehow that's supporting this performance. But a rather different explanation is just to say that the stimuli look different at these two different SOAs. And so a different response criterion is set in response to the seeing question. So Yonasi and DeLollo discussed this and pointing out that at a short SOA, the stimulus kind of looks like this blended figure, the mask and the target blend together. That allows you to do the task. You can tell whether it was a diamond or a square by looking at this. But you can understand why a subject might be more reluctant to say that they saw the target in this case, because what they saw was this kind of blended figure. Whereas in this case, at the longer SOA, you're getting a clear and distinct presentation of the target and the mask. So subjects might be more liberal in reporting seeing. Okay, so in relation to blind sight proper, the point is just that if the contents of the blind field differ, as we might suppose they do, they appear differently, then GY might set a different criterion, a particular conservative criterion in the blind field, and that might generate the pattern of performance we see. Okay, second critical objection is that the qualitatively degraded conscious vision approach can't explain a distinctive dissociation of force choice and yes-no sensitivities in blind sight. So kind of a theorem of simple detection theoretic models, one that's been experimentally established, if not entirely uncontroversially, is that with neurotypical subjects, we can relate force choice and yes-no detection by a particular square root rule. So D prime in force choice detection is going to be equivalent to root 2 times d prime in yes-no detection tasks. However, in Blindsight, it was discovered by, in fact, Paul, who's with us today, and Alan Cowie in the late 90s, that at least with GY, there's a distinctive dissociation, that his force choice sensitivity is significantly higher than you'd predict by this square root rule in special relation to static stimuli. So this was not the case for moving stimuli, it was the case for static stimuli only. So here is the data from GY showing that dissociation. This is force choice sensitivity and yes-no sensitivity corrected with the square root rule. And here you can see various control subjects not exhibiting that. I take this to be Paul. Okay, so on the face of it, this suggests that there's signal available for two-interval force choice discrimination, but not for yes-no detection in GY. And that looks like it's consistent with the account on which unconscious information is available in Blindsight to guide forced responses of this kind, despite being unavailable for conscious detection. So that would be as it were, the orthodox account. And so that's the kind of lesson that people like Lau and Weisskranz want to draw. Okay, my response to this is that I think there's good reason to resist this line of thinking. And that's really because estimates of D prime or similar statistics are really assuming that a subject's criterion is stable across trials. Now, if a subject's criterion is unstable, if it jitters, then that, as this diagram is kind of helpfully illustrating, is mathematically equivalent to moving the distributions. So the effect of that, of course, across trials is to increase the apparent variance of those distributions, the signal and noise distributions. And that in turn is going to lead to an apparent decrease in yes-no sensitivity, because that's measured in terms of the standard deviation of these distributions. But because, as I kind of implicitly brought out in talking about two alternative force choice designs, those designs are effectively criterion free. The subject is just choosing whichever interval has the highest stimulation in it, regardless of their own criterion. This is a distinctive effect on yes-no detection responding. So if the criterion in GY is responding is jittery, then that will artifactually lead to an apparent dissociation of this kind. So this is a suggestion made by Azzopardi and Cowie themselves in 2001, and supported by evidence they had of sequential dependencies in GY's responding. So again, that's another feature of GY's sort of profile that needs explaining, instability in his criterion. And I'll try and return to that later. Okay.
You there, Ian?
Hey, sorry, I think I just cut out for a second.
No problem.
Can you, okay, sorry about that. Don't know what happened. Okay, so let me, I think I'm gonna skip over the next thing, which is to explain GY's apparent failure to succeed in exclusion task. The basic, I'm happy to go and talk more about that in Q&A. The basic answer to that is that don't think exclusion tasks are criterion free. And so again, there's going to be a response to appeal to his conservative responding. So let me just talk about another two objections. So fourth objection to the idea that Blindsight is conscious vision is that the functional profile of Blindsight does not fit that model. And this objection is sometimes put by observing that residual performance in blindsight is only revealed in forced response or forced choice settings, or that it requires cueing, though Petrosteric has a paper suggesting that may not be right. And the objection is often put by appeal to a kind of a throwaway remark that Tony Marcel made to the effect that a thirsty blindsight patient will not reach for a glass of water in their blind field. Now, as Marcel surely knew, that the vision in the blind field is not sufficient to observe things like glasses of water and whether they're full or not, or anything like that. But the point is that you don't apparently get spontaneous responding to stimuli of which there's residual vision in the blind field. But the basic answer to this worry is just that a lack of a spontaneous response could easily just reflect a conservative response criterion. So, I mean, spontaneous actions like reaching out for a glass of water are no less the product of sensitivity and some kind of response criterion than our verbal reports or button presses. So if GY has a conservative response, he doesn't think he sees anything, then there will be no reason for him to spontaneously reach out for such a thing as a glass of water. And in ways to flip the argument on its head, you might think what's clear from blindsight is that visual information is available to inform voluntary action, even if it's not exploited in spontaneous action. And you might well think that the availability of information to inform voluntary action was a reasonable ground for thinking, at least everything else being equal, that the signal was conscious. Okay, final objection. And this concerns some alleged impairments of metacognition that are found in blindsight. So in a couple of papers by Passau and colleagues, it was alleged that GY exhibits a distinctive impairment in metacognition. So in one paper, in a yes-no detection task, GY was able to make 70% correct detections, but then when given the chance to wager, did so optimally on his decisions only 48% of the time. And in this task, which is shown, GY was given a spatial to alternative forced choice task, which he had to make a judgment of in which interval was the vertically oriented grating. And then given the opportunity, having made that judgment, to either place a bet on his response, where he'd win 50p, depending on the correctness of his discrimination or not, or lose it, or flip a coin with a 50-50 chance to win or lose that amount of money. And the results here was that in his blind as compared to his sighted field, despite their matching performance, his decisions to wager correlated significantly more poorly with his discriminative accuracy in his blind field than they did with his sighted field. Okay, so how should we interpret that? Well, the way that they wanted us to interpret it was to think that his type 1 sensitivity is somehow not available to awareness, not available to metacognition, or at least less available than it is in the sighted field. Now, I think there are lots of problems with this reasoning. And the most kind of obvious to me is that both of the two tasks, actually in both of the experiments, have a weakly dominant strategy, which is completely independent of any metacognition. So in this task, the best strategy is always to bet on your discrimination. So ignore the coin flip completely. And why is that? Well, your discrimination is probably at worst going to be 50-50, even if you were blindfolded and couldn't see the stimulus at all, just for guessing. So the coin flip is just equivalent to discrimination with zero sensitivity. So no matter how underconfident you are, as it were, about how much sensitivity you have and how good you are at the task, you might as well bet on it. So that suggests that you don't need any metacognition to perform well at this task. And so how can it be a good measure of metacognitive sensitivity? It's also true that the measures of metacognition employed don't deconfound type 2 sensitivity and bias. So you can explain what's going on in terms of suboptimal wagering, in terms of loss aversion, as opposed to any lack of awareness. But also, I think it's just not clear what the significance of, as it were, metacognitive sensitivity or intersensitivity really is. So there are lots of things that could be going on which might explain why there'd be a, as it were, metacognitive insensitivity, even if measured objectively. And it could, for example, be that there's a loss of information following the discrimination, or additional or differential noise in respect to that type 2 decision. But you might also just think metacognition was just independent of first order awareness. So for all these reasons, I don't think these are kind of, this line of evidence is probative in relation to whether blindsight is or isn't conscious. Okay, let me now turn to a positive case for thinking that blindsight is conscious degraded vision. So the first reason I want to put on the table and then not discuss at all is just that this is a simple hypothesis. Okay, so I think we're already committed to thinking that voluntary actions, sometimes at least, are explained by a conscious visual signal. So if we can explain performance in blindsight in the same way, then so much the better. Okay, that may or may not be a compelling reason for you. The second reason that I want to focus more on is that standardly assumed in detection theoretic models that response criteria are flexible things, that they can be manipulated in various ways. So if what's kind of masking the awareness in blindsight is a conservative criterion, we should expect to be able to manipulate it independently of the stimulus itself and get illicit reports of awareness. Okay, and finally, and much more broadly, I think if we look at the behavioral data and sort of first-person reports from patients like GY in the round, then we can tell a satisfying explanatory story about why there is conservative and unstable responding. So we can have an understanding of what it's like to have blindsight, which would fit with the picture that I want to defend. So let me talk about this idea of varying the criterion. So one way in which we might think about a criterion as being varied is by varying the question that we ask of the subject. So slightly misleadingly, I showed you this perimetry at the beginning of the talk, which is perfectly representative of perimetry in GY. And the question that Sturrig and Barth asked there was, you should press the button when you see something. And this is the result we get. But they also asked the second question with exactly the same stimuli, press when you're aware of something. And suddenly that simple variation in the question leads to a very different pattern of response. Okay, we're seeing positive responses throughout significant regions of the visual field. Now, Weisskranz is quite aware that you do sometimes get reports of awareness in blindsight, but he denies those should be construed as reports of conscious vision or seeing anything. These are reports of so-called type 2 blindsight, where residual performance is accompanied by feelings, but in his view, never visual qualia or seeing. Now, I'm not entirely sure I know what we should think about, what visual qualia precisely are, but it seems to me, for one, much more parsimonious to think of these results as reports of degraded vision. But there are actually experiments, if you look, where GY does seem to just simply report seeing. So that wouldn't fit with this account. So in the Kentridge study I mentioned to you before, the 2ISC detection task, in one particular condition where they told GY before the trials, the location of the stimulus, that it was going to be in a horizontal location, GY performed extremely accurately and reported awareness on 65% of trials and said that he was seeing a lot. So that's some evidence that there's actually also reports of seeing also. And this may have to do with changing his prior and therefore shifting his criterion in that respect. Okay, another way in which we might manipulate a subject's criterion is by shifting the response options from a binary, yes, I saw it, no, I didn't, kind of option to a more nuanced scale. In particular, we might use Ramsay and Overgaard's perceptual awareness scale, where there are 4 options: 0 for didn't see anything at all, no experience; 1 for weak experience; 2 for almost clear experience; and 3 for clear experience. And with a patient SL with Blindsight, Chiara Mazzi and colleagues looked at performance across a range of different conditions, using first a yes-no measure on a trial-by-trial basis, and then in the second experiment, same conditions, but with this graded perceptual awareness scale. And the results are really very suggestive, I think. So what you can see here is that these black bars are corresponding to no, guessed, unseen responses. But that black bar turns into a gray and black bar in the perceptual awareness scale experiment. So in other words, it looks like this patient is collapsing zeros, i.e. no experience at all, and ones, i.e. weak experience, into this unseen category. And then if you look here where you've got seen responses, those are all corresponding to level 2, almost clear experience responses. So this suggests that when this patient is at least saying didn't see, they're reporting either weak experience or no experience as they see it. And when they're reporting C, they're reporting at least almost clear experience. In this particular study, there was no evidence of above chance discrimination in cases where they only looked at the 0 ratings. I'm not sure how much weight can be put on this because performance was very low in lots of the conditions, but still I think this is very suggestive and fits with other bits of data where it seems like you get patients where if they report awareness, they're performing above chance, but if they don't, they're not. Okay, I think I'm going to skip this next slide, which is talking about the ways in which we might vary motivational factors and move on to this kind of question. So what is it like to have blindsight? I mean, that's a question that you wouldn't even ask on the traditional view, but is clearly a pressing question on my kind of interpretation. And I want to just look at some behavioral data and then some first-person reports from GY to tell a bit of a story about that. So the first thing to say is that blindsight is really degraded vision. If GY was conscious throughout his blind field, as I suggest, he'd still be classed as blind by any kind of conventional classification. His wavelength and orientation sensitivity is impaired by an order of magnitude, contrast sensitivity by a couple of orders of magnitude. And I said to you earlier that DB could discriminate simple shapes. So it looked like you were getting perception of visual form in blindsight, but Weisskranz later suggests that's not in fact true. DB was unable to discriminate differently oriented triangles or rectangles from squares, suggesting that he's not really picking up on form proper when he's seeing X's and O's, but rather maybe some simple low-level orientation component, just like an oriented edge that's distinctive of one rather than the other. Again, I think in a really interesting study by Alexander and Cowie, there's also some really sort of suggestive evidence of the, as it were, criterion contents, which are the bases of often of discriminations in blindsight. So what they looked at was performance with a couple of patients, including GY, in detection tasks. And what they varied was whether the stimulus had a sharp edge, or rather was a Gaussian, as you can see here. And they also varied whether the stimulus had a sudden onset or offset, So it would just appear on the screen suddenly like that, or go away suddenly, or instead it would be ramped off or ramped on the screen very slowly. And although not every condition was considered, the basic upshot of the data was that where there was no sharp edge and there was no sudden onset or offset, there was no above chance performance. So performance was seen to be wholly reliant on the ability to detect a sudden spatial or temporal discontinuity. And so that leads to their suggesting that maybe GY is really only detecting events. He's not detecting the presence on the screen of an object, of a visual object, but rather only some kind of shift in salience, either spatially or temporally. And that goes back to an early suggestion of Humphreys. Okay, so let's now turn to some of the things that GY says about his experience. So one thing that he stresses is an absence of color sensation. Another thing he says, this is in a PBS interview, says that he's aware of individual functions of sight. Like he's sometimes aware of motion, but when he is, that motion has no shape, no color, no depth, no form, no contrast. Sometimes I can tell you what orientation it's at, a stimulus, but everything else is lost. So sort of suggesting that there's no perception of bound features, of objects with multiple features, but merely of maybe the presence of a single feature or some basis for detecting the presence of a single feature, like motion or orientation. Interestingly, he talks about how moving objects don't appear to have any color or shape. They look like shadows. And any of you are familiar with kind of phi apparent motion. You might think of some of the descriptions of subjects reporting that kind of flag-like shadowy motion between stimuli. Kind of poetically, at one point, he talks about seeing motion as being like black on black, again, recalling certain kinds of phi apparent motion. There's a mouse under a blanket, similar to that of a normally sighted man who, with his eyes shut against sunlight, can perceive the direction of a hand waved in front of him. And again, really interestingly, another thing that he once says is that spontaneously, in a study by Zeki and Fish, that his awareness score on certain trials should be -1 or -2. And there, like, one small point is just that, well, unawareness, like complete lack of awareness, surely can't come in degrees. So that last remark suggests that what's being reported normally as unawareness is sometimes, as it were, level 0 awareness is kind of weak consciousness rather than genuine, true unawareness. And that, I think, fits rather nicely with what we saw in the Marzi study, this collapse of weak and absent awareness into one category. But the more general point I want to draw from these reports and from the earlier work, the behavioral work, is a striking contrast with ordinary vision, which GY gets around with in his cited field. There's no color, there are no bound objects, there's no visual form. There's perhaps only representations of something like feature-specific conspicuity, like how much a given location stands out in respect of a given feature, or maybe salience, which is even perhaps feature agnostic salience. And so that's like a key point to bear in mind as I now finish up and discuss why you might get the criterion patterns that you do. Okay, so that's what I think it might, in a very rough way, be like to be blindsighted. So why, though, if there is conscious vision there, is it not reported? Why is GY so conservative? Okay, so the first thing to say there, by way of background, is that all of us pretty much are conservative when we are near our threshold. So you might think of that as a tendency to set a threshold that avoids a certain number, maybe 5% or 1% of false alarms. And as you get poorer and poorer in your visual discrimination, then that's going to lead you to set a more and more conservative threshold. So this is some data from Anderson's thesis about subliminal perception and various things, where he just plots the criterion and sensitivity of neurotypical subjects in a masking paradigm. And what you can see is that as detection sensitivity is getting worse, the criterion being adopted by the subject is getting more and more conservative. So in fact, almost all of the people are adopting conservative criteria, and they're getting significantly more conservative as we trend towards lack of detectability. Now, this is extremely rough and ready, and so you shouldn't take it too seriously, but we could try and map what GY's pattern of sensitivity and criterion setting might be like onto this figure. And I've done that by taking some data from Hazapadi and Cowie's paper and just plopping it onto this chart as a red dot, making lots of unwarranted assumptions. But if you look at that red dot, it's an outlier for sure, but it's not wildly off the chart. So the first thing to say then is that the pattern of responding, given this kind of sensitivity, is not absolutely extraordinary. And criterion setting is clearly really variable as well amongst neurotypical subjects. So another question to raise is, well, how representative is GY's criterion setting of a broader population with the same pattern of sensitivities? It's not really a known question. Okay, so that's background, but the main thing I want to say about GY's criterion setting is that his residual capacities in the blind field are so qualitatively different from sighted vision. You remember, no color, no bound objects, no visual form, perhaps only salience or conspicuity, that he's quite plausibly reluctant to call it genuine vision, perhaps as opposed to awareness, or perhaps not even to count it as that, especially when you're using binary measures. And so that's, I think, the central thing that we want to appeal to. Another background thing to mention, which I think is always worth bearing in mind and hard to really assess, is how much GY's own self-conception is playing into his criterion setting. And there's some evidence that his criterion setting varies depending on his read of the experimenter's expectations. But I mean, he's not a naive subject. He's participated in a huge number of long, arduous studies since he was a young man. He's done in ways a huge service to science in doing so, and sort of traveled around a lot, and psychophysical studies are not fun. He's regarded himself as being blind in his right half field since he was 8 years old. So that's just part of his conception from childhood onwards. And he also, I believe, reads his own literature. So he's very familiar with various of the controversies about Blindsight. And most of those studying him, certainly Weisskranz, are typically proponents of the hypothesis that the visual function in Blindsight operates outside awareness. And I mean, indeed, in the PBS interview that I mentioned, like he comments at one point that he has a lizard. He's in the Cotswold Wildlife Park or something like that in Oxford, and he's standing by a lizard enclosure, and he comments that his vision is like the lizards because it's an older, different pathway that he's relying on. So he's clearly got a kind of self-conception of what is behind his allegedly unconscious vision. It's quite possible that all those factors feed into the idea that it's not awareness, whatever else is going on in his blind field. Okay, very last thing to say. One about the distinctive psychophysical signature, this dissociation of yes, no, and alternative forced choice responding, and the explanation that I've floated about criterion instability. Well, one idea here is that, I mean, in general, criterion setting isn't that well understood, but one important approach is Treisman's criterion setting theory, on which we think in general that optimal criteria are maintained by two different mechanisms working together: a stabilization mechanism, which is kind of working to avoid extreme criteria, that's tracking how far on a given trial the sensory response is from your current criterion, and then adjusting the criterion towards the response. So if you say yes on a given trial, then your criteria is going to become more conservative on the next one, in effect. And then a probability tracking mechanism, which is in effect exploiting an assumption of environmental continuity, and works in the opposite way. So a positive response on a given trial is going to lead to a criterion becoming more liberal. So in effect, updating your prior to reflect an increased prior probability of the same stimulus occurring. And those two mechanisms, details aside, receive two kinds of input on this theory. One is input from recent traces of sensory responses. So they're weighted and decaying those traces, and they're fed into these mechanisms. But Treatment also postulates a projection mechanism whereby traces from older previous encounters where you've made discriminations are stored and can be projected into this pool of tracing. And the important point here is that this pool of traces, the larger it is, the less significant a shift there's going to be as a result of these mechanisms because of the latest trial. Okay, so the more traces you've got, the more projected traces, and I guess the higher weight you assign to traces from previous discriminations, the more stable your criterion is going to become. And if you've got a large pool of traces from earlier encounters that are stored and projected, then that's going to lead to what they refer to, Martin Large and Nicole Treisman in a paper, as a permanent or quasi-permanent criterion. So they use this idea that to explain anisotropies in discrimination. So in particular, we're better at discriminating deviations from the vertical, which is, I guess, a familiar, commonly discriminated orientation, likewise the horizontal, than just deviations from random angles in between. So you could understand that as reflecting the fact that we have more stored traces of discriminations made in respect of vertical orientations. We can apply the same basic idea to blindsight. The idea would be the more you discriminate, the more you stabilize your criterion by building up this pool of traces to feed into these mechanisms. And then we think, well, in sighted vision, there are going to be lots of traces because we've used our sight a lot. And so we're going to have much more stable, permanent, quasi-permanent criteria. But recall that vision in the blind field is really severely degraded. It's not what someone like GY uses in everyday life to get around Oxford or wherever he now lives. So the non-functional fact and the degradation of the vision itself can be used to understand the fact that there may not be a significant pool of traces that will help to stabilize the criterion. So there will be much more trial by trial variability as a result of this particular aspect of criterion setting. Okay, so the basic idea then is that the fact of the qualitative difference and the degradation of the vision can be used to explain both the conservative and the unstable criterion setting, and therefore account for the psychophysical profile we find. Okay, so let me just end by drawing some lessons and commenting on a few kind of future questions. So one lesson, I think, which I'm particularly interested in from a kind of philosophical perspective, is whether the obvious assumption that Pat Churchland describes as blindsight having refuted is in fact just correct. So is it right that awareness of a signal is a necessary condition for an intentional response to that signal? So I'm inclined to think that that might be right, and blindsight at least is not a counterexample to that claim. The second kind of question is whether we can tell a similar story or give a similar account of a range of other performance awareness dissociations that are found in other cases of cognitive neuropsychopathological cases. So in maybe neglect, in prosopagnosia, in amnesia, visual form agnosia, like patient DF. So I think all those things are really worth serious investigation and may be amenable to a similar kind of account. Also, I think that it would be worth considering whether a similar kind of account could be applied to various cases of unconscious perception in neurotypical vision. And I just want to end by making an advert for those of you who go to VSS for a presentation that will be there on just such a case. So this is a bit of work that I'm currently doing with a couple of colleagues at Johns Hopkins. I'm sure you know, Howard Egeth and Chas Firestone, and led by a graduate student, Michaela Nartka, where we're looking at inattentional blindness. And so we're just using a kind of classic Mac and Rock type display cross-task, where on the first few trials, the subject has to say which of these arms of the cross is the longer one. And then on the critical trial, we're going to display a stimulus, and it's either going to be a red line like this or a red line like this. And the key thing that we're interested in is usually in these discussions, we simply ask subjects, did you notice anything unexpected on that critical trial, the fourth trial, which wasn't there in the previous trials? And that's clearly a question that's subject to a huge amount of response bias. So the point of presenting the line either on the left or the right is so that we can look at a super subject level at the two alternative forced choice performance in subjects who have declared that they didn't see anything on that trial. So amongst those non-noticers, the people who would normally be classed as inattentionally blind, we're finding in a number of conditions that there's significantly above chance performance. And so one way you might interpret that kind of result, and there's a lot to say about this, is that it's not really inattentional blindness, but rather inattentionally degraded conscious vision. Okay? This kind of account, I'm thinking, kind of has a lot of scope to the future investigation. Okay, and with that, I will thank you all for your time and attention. Thank you very much.
Thank you so much, Ian. That was great. So we'll open it up to questions.